So we're going to talk. Okay, so I'm just going to. It's not a really complicated lecture. I think just kind of a couple of things. We're going to talk about what's called the enhanced for loop, and we're going to talk about or it's called the for each loop, and we're also going to talk about the system array copy method. And so it's not really, there's nothing really that theoretical about it. Just some new features of the language. Um, and here, okay, so hold on here. Maybe I can also open. Hold on, I'm gonna see if I can also open Eclipse up. So, oh, sorry, so I thought I had my file. So just give me a second. I thought I had my files. Oh yeah, I do have them open. Okay, so this is open, and this is open, and then is Eclipse open? Probably not. Okay, Eclipse will be open soon. Okay, so I'm going to go back here. Hopefully I haven't messed everything up. Okay, so I'm going to share. Yeah, I'm not super organized. Okay, so I'm going to share here. I'm going to share the screen. And I believe I put these, they're under files, there should be these two PDF files. One, yes, the for each loop and the system array copy. Okay, so right now what you should be seeing, do you see, okay, so do you see,
Yes,
well, it should say for each loop. And you see that? Okay.
yes.
And so, and this is kind of like it's a special type of for loop, and you see it a lot. When I first learned Java, we didn't have this, and then at some point they added it to the language. And I remember I learned, "Oh, this is strange. It looks kind of complicated, and it really isn't after when you get the hang of it." Okay, so hopefully we all know how to write a for loop, or if you don't, you'll just remind yourself really fast of how to write a for loop. And um, so what we're going to learn learn how to write a for each loop, and it's also called an enhanced for loop. And so uh, and the regular for loop, sometimes I call it like the math 130 for loop. I don't know what, it's just a for loop, okay? But I don't think there's like a special name for, but just to distinguish, sometimes I call like the traditional for loop, which is my own term, or just the math 130 for loop. But the for each loop, and you see it a lot in the book, so especially, and we're going to use it throughout the course. It's really very common in Java. And so it's just a way to iterate over an array or every element like in a collection. Like an array list is a collection, and we're going to learn about linked list, and a linked list is a collection. And um, and uh, um, and you actually look at every element. For each loop will look at every element like in an array. Okay, so here's just the format, which if I was looking at this would be meaningless to me. But it's the keyword for, and then followed by the set of parentheses, and you say the data type of the collection, like the data type of the array, and then some kind of like counter variable, and see that colon there is read as in, and on the right side of the colon is the array name or the array list name, and then some Java statements. So why don't we actually, of course, this is, okay, go ahead and start programming with for each loops. Okay, so here is, if you have never seen a for each loop, there it is. So, ta-da. Okay, so here, okay, so first you should see a slide that says example 1. And it says double square brackets, double ARR. So the name of the array is double ARR. And how do you know it's an array of type double? Well, you see the variable name double ARR, and you look to the left, you see the square brackets. Oh, that means array. And then you look to the left of that double. So double refers to a list of double values. That means double ARR refers to a list of double values. And then on the right side, we hard code the values. We initialize the values. And so the length is going to be 4, and the first value is 9.183. I think you can see it. So we hard code 4 values. Okay, so now our goal is let's display the values. And so we could use like a regular for loop. And so we'll actually write some code. We'll do some print, to see an example here, to see that it really works. But let's just look at that for loop. And I wish I'd opened that up in Oh, whatever. Okay. Yeah, I didn't help them in PDF annotator. Okay, so first of all, the for loop, we always see the for loop. So in an enhanced for loop, we still see it's still for, and it's still followed by the set of parentheses. Now, what's inside is not what we see in the traditional for loop. We don't see the like the three parts. So like in what you learned in Math 130, there's an initializer, and then there's a Boolean expression, and then there's an incrementer. So here what we see is, how would this read? Well, I have the words written right there. For every double value in double ARR. Remember, double ARR is just the name of the array, name I assigned to the array. So that colon, the colon is read as in. For each double X in double ARR. And what we're going to do is X, and so we're not using indices at all. Yeah, so I have a slide later on. If you're using an enhanced for loop and you have an index, then you're doing something wrong. So there's no indices. We totally forget about indices. Indices are for the the for loops we learned in Math 130. So X actually is a value that's stored in the array. So the first time X is 9.813, and then the second iteration. So we keep iterating, right? So this loop iterates. So the first time X is 9.813, and then it just goes down the line, 11.697. In the third iteration, X has the value 55.342, and then the last value is negative 1.0008. And so what we're going to do is we're going to display it in formatted output, 2 decimal places of accuracy. But the important thing is what's inside the parentheses. For every double value X in double ARR. So if you just think of the array as like a set, like a set you learn in your algebra class or your calculus class, we're just the counter variable X just will just take on, just one by one, take on every value. And so the for loop, the number of iterations of an enhanced for loop is always equal to the number of elements in the array, or maybe the number of elements in your array list. And so we'll see in a second, we can use the for each loop for an array list as well. So any questions right now? So it's really not too bad. You just have to, just get used to it. Okay, so here's
Professor.
go
Yeah, I have a
ahead.
question.
Yeah, go ahead.
You said that so at the end when it's system.out print, when we print out the list, the X represents every item in the array.
So you mean, okay, so you're talking about example 1?
Right. So at the bottom after the for loop.
Okay, so that's actually in the for loop. So you just see that for loop, and then you see like the curly braces.
Right, but the double X, is that initializing the double array? Or I'm kind of confused.
Okay, so the first time X is 9.1. No, so the statement right here is, hold on here. Let me see if I can get my pen, which of course I have. Okay, so I might actually close this file and open it up again in PDF annotator. Maybe that'll help you. Can you just give me a second? I should have brought my pen with me, and I will go. That's not good. Okay. Okay, so I definitely need to get a new lamp. Okay, so I'm back.
So I guess my question is, does the enhanced for loop, does it declare the loop variable? And
The
then
only
it
thing that it's
defines it with
declaring
the
is
element?
X. The only thing it declares is X. And it
Right,
doesn't
and
have to
then-
be X. There's nothing special about X. Okay, so here, I'm gonna just close this and I'm gonna reopen it, okay?
Yeah.
Okay, so I'm gonna close this. I'm gonna stop sharing. And then I'm gonna reopen this. So I'm gonna reopen it in this PDF annotator, which I always, I guess if I was, this takes a second. Here we go. Okay, and then let me share this again. Yeah, that's right. It's the item. Okay, so let me just share here. Okay, oh, stop. Okay, so the for each loop. So now hopefully I can write on the screen a little bit. Okay, so so now you should see the slides again, only now it's open up with the PDF annotator. Yeah, so this is, okay, so this is where we were. And let's see if I can, so this is, okay, so this is the only thing is right here. This is the only thing that's, whoops. So, okay, hello. This just doesn't like me, does it? Well, so much for this PDF annotator. I don't know if it's just slow or what here. Okay, so let me just try this one more time. It's not doing a very good job of right. Oh, I'm sorry, students. Sometimes this is just so clunky. Yeah, there we go. That's the variable. See, that's the only thing that's being defined in the enhanced for loop is X. Is it? Does that answer your question, Philip, or were you asking that? Was it a different
I
question?
think he meant that. I think he's asking, is the double X, is the X represent an item in the double array?
Yeah, yeah.
What?
The first time, yeah. So the first time X will be 9.18.
And then it follows. Got it.
Right.
So
Yeah.
it's kind of like a for loop. I mean, like the original for loops, basically. Like,
Right. So like
Updating
so in this case,
updating a
X is
variable.
like, yeah, X is like double ARR. So X would be kind of like in a regular for loop, we'd be using double, we'd be using the name of the array, only we would be using an index.
Got it. All right.
Does that help?
Yeah, it's a little bit more clear.
Okay. Right. Okay. Yeah. So X. Yeah. So we don't use the index. So X just takes on a value in the array. So we forget all about the indices. So X automatically just moves down the array. So for every in the first iteration, X is 9.813. And so we'll write one of these with Eclipse, and hopefully that'll clear up any issues. But is it okay to go on to the next problem or the next example? No crises or no. Okay. Okay, so do you remember array list from Math 130? And an array list is, you can think of an array list as kind of like an infinite size array. You know, an array actually has a fixed number of values. Okay, so in this case, so in this case, the array list is, it says that's kind of maybe what's a little special about the array list. It's got the diamond operator. And inside the diamond operator, it says exactly the kind of values we can store. So it's saying, the array list is called ARR list. And it can only store strings. You try to add anything other than a string, you're going to get a compiler error. And the way to add to an array list, it's actually an object. An array list is actually an object, and we add with methods. And there's this add method. So to add to an array list, we have to, so the name of the array list, so that variable ARR list, you look to the left, and it tells you exactly what kind of data variable it is. In this case, it's an array list that can store strings. And to add a string, you have to just use the add method. So we add cat, house, and hello. So we have this kind of like this kind of array-like structure, and it's storing these three values: cat, house, and hello. And we can use the for each loop on an array list as well as an array. And so what we're going to do here is just count up. It's just add up the sum of the add up the sum of the string length. So it's 3 plus 5 plus 5, which is 13. Okay, so here's what's special. What kind of data is stored in array lists? I mean ARR list. See how we say it's an array list of strings? And isn't that what we say right here? Let me just underline this. So for every string S, and then there's the colon operator, or I typed it out. For every string S in ARR list, and the first time S is cat, so then we're going to iterate, right? In the first iteration, S is equal to cat. In the second iteration, S is house. And in the third iteration, S is hello. And then we just add on the length. So then you could also go sum is assigned sum plus S dot length. So S is it will always be a string. So the first time it's cat, and then the length method is it's a method of every string object. It tells you the number of characters in the string. So the first time you're going cat dot length, and the second time you're going house dot length, and the third time you're going hello dot length. So it's 3 plus 5 plus 5, and you'd print out 13. So So let's just do a few more examples, and then I will, hello, I will, we'll open up Eclipse and try to run some code. Okay, so, so these two examples here, this is all it is, right? See how short it is? I think it's just, it's different. So it's like you're so used to maybe the regular for loop. Like, are people chatting with me? Which is good. Okay, as long as you, okay. Oh, maybe nobody's, okay, let's see. It's all happening so fast. Oh, no new chat message. Okay. Okay, so, but these two examples, that's all there is to enhance for loop. You just have to say the date. So right after the for, after the left parenthesis is the data type of the collection, and that's followed by some legitimate. You decide on the variable name, and then that's followed by the colon operator, which means in. And to the right of the colon operator is the name of the array variable or the name of the array list variable. So it reads kind of like, if you remember that colon means in, it reads almost like English for each double value in a double ARR. So, or for every string S in ARR list. Okay, so here's some things that you don't want to do. Okay, so for each loops, do not use array indices. So, and that's a common error I see a lot. And if you're using it, like, see how I have this index X square bracket I? First of all, X is not actually an array. The array is ARR, right? So if I'm looking at that, this slide 6 there, for each loops do not use array indices, right? So the array name is actually, here's the array name, ARR. And X alone is just an ordinary integer, right? X alone is just an ordinary integer. So you do not use indices. Don't use indices when you're working with for each loops. So if you're using indices, you know that you're doing something wrong. And I see that a lot. I think sometimes it's rush or they're getting, it happens when we're nervous or we're still learning it. Okay, so I'll go on. Oh, here's the other thing, students. For each loops are good for reading data, but they're not good for, they're good for reading every element of the array, but you can't change the array. So if you want to change an element of array, you have to use an ordinary for loop. Okay, so here we have that same array, 3 values, 99, 71, 1001. And I'm trying, I see how in that for loop, I'm saying, oh, let's assign X is a 9. Okay, but it doesn't actually change the array. You can't change an array with a for each loop. So for each loops are just for reading operations, not for like writing operations. It's not for assigning values to an array. And the third thing is we can't skip iterations. So if you only want to look at like some of the array elements, so let's say you want to print out every value of an array, but only like every other one, like all the ones with the even indices. Then once again, you have to go back to an ordinary for loop. So the number of iterations for each loop will be identical. It will be equal to the length of the array or the length of the collection. And that's all there is, students. I thought maybe we could try one in Eclipse just to verify that it works. Is it okay to, I'm going to stop sharing this unless there's any questions. Again, this is online, and the slides for the system array copy method are also online. And then we'll do some more of it. What is today, Wednesday? We'll start by reviewing this on Monday. I want to show some examples, especially with system array copy on Monday. And then I forgot what new thing we'll talk, generics. Maybe we'll talk about generics on Monday. Yeah, maybe we'll talk about generics on Monday. So, and I'll post an assignment for you tomorrow. Sometime tomorrow, we do like a week from Monday. So, okay, shouldn't be too bad. So I'm gonna stop sharing. Okay, any questions right now before we open Eclipse? Okay, so. Oh, hi, Austin. I see someone's joining the room. Okay, let's see here, Eclipse. So let me just share this. And okay, so I'm just gonna, what's the name of this file? I don't know, I have this open, so I'll use this. Okay, so no, this is not what I wanted. Oh, I have too many files open. I don't really need to close all these, but oh well, okay. Okay, so let's actually, why don't we look at, okay, here, let me just, I have this written already here. So I'm gonna, okay, let's say we have this array right here. So it's array, so can everyone see that? You should see an eclipse, or it's an eclipse. And I have this, there, like on line 49, you see this array called X. Maybe I'll call it something else. I'll just call it ARR, okay. And you see that array ARR that I've defined, it has 4 values in it?
Yes.
Okay, and we can even add one more. It doesn't matter, 5.1. Okay, so now why don't we just print out the values with an enhanced for loop. So the name of the array is ARR, and the data type, what's the data type? Every individual element in that array is a double. That's the important thing. Okay, so for okay, yeah, so for every double X in ARR. So in the first time, and it doesn't have to be X. I keep using X. Why don't we just use T? Okay. So for every double T in ARR, and again, T, what's really required here is double, because we're looping over this array ARR. Okay, so we have to, so we start with the data type, which is double, and to the right of the colon operator is the name of the array. This counter variable that's directly to the left of the colon, it can be any legitimate variable. There's nothing special about T.
Professor,
Oh, go ahead.
what if I didn't have a double value and I try to do the enhanced for loop? Would it still work?
Well, in this case, look on line 49. We have a double array.
Right.
We have an
So,
array.
oh, I was just curious because I know like I could put the value, let's say just 1 without 1.0.
Well, maybe like if I put int here, I don't know that it would. I don't know. You know, I'm going to be honest. I don't know. Let me
Okay.
try. Let's try and see what happens. Does it complain? Yeah. See, what does it say here? Yeah, can't. Yeah, in this case.
Okay. Well, I mean in the actually hard coded the number. So you have 1.0. What if you just put 1? Would it still work? Is what I mean. Like on line 49.
Oh yeah, no, you should be able to do that.
Okay. I was just curious.
Yeah, in this case, yeah, because you can actually assign a double to an int.
Okay.
So yeah, okay, so okay, yeah, you can always assign a double, but not the other way around. Okay, so okay, here, so for every double T, yeah, so the first time T, but it's really one, like the first time T is 1, but it's really 1.0 because T is a double value. So like if you go
Okay.
like this, like double, like if you went like this, double S is assigned 1. So what in reality S is actually 1.0.
Right. I was just wondering if it would still work.
Oh yeah,
That's all.
definitely. Yeah, for
Okay.
the it will.
Okay.
Okay, so now let's okay, so now what are we going to do here? So let's just print these out. Okay, so for every double, okay, so then system dot out dot, let's try this if I can do the print off the top of my head. Okay, so how about value equals, and then what is it? It's percent 1.2f, and the slash n, that'll be for line break, right? You have to force the line break with the printf. And what's the name of the variable? And then we're printing out the latest value of t. So it says, yeah, so this is format. Yes, you see that percent. So that means it's a formatting character. We're doing some formatting. And F means we're printing a double. The 1.2 means use at least one space to display and use 2 decimal places of accuracy. And so let's just see what happens. So the first time T should be 1, and then it should be 3.14. Let's see if I can, hello. And see it, we can't see the numbers right now, but you see how, yeah, we have the remember it was 1, and then it was pi, and then it was, what numbers did we have here? Yeah, you see how we had, yeah, so then the 3.128 formatted to, you know, we rounded to the nearest 2 point value, because we're doing 2 decimal places of accuracy. So after each number, there's 2 decimal 2 decimal places, exactly 2 decimal places. Okay, but you know, this really wasn't so bad because I mean,
Professor, I got another quick question.
yeah, go ahead.
I'm trying to remember from Math 130. So the 1.2, I know it shows 2 decimal, and then the 1 space. Where's that 1 space at?
It means use at least 1 space.
Okay.
Let me show you something. Let's say I made it really big. So let's change this to like 10. Let's say so for each value we're going to use we're going to use at least 10 spaces.
Okay.
Now, these numbers like 1 doesn't need 10 space, and we'll use 3 decimal places of accuracy. Let's put some more numbers right here, 6, 7. Oh, that's not good, is it? Okay, so we're gonna see now. We should see gaps now because the number 1's gonna be. We're gonna use 10 spaces to print out the 1 and 10 spaces to print out the pi. And the period, like the decimal point, is one of the is one of the spaces. So let's see what happens here. Oh, because it's on. Yeah, you see it because it's on different lines. Okay, so and it's right
Okay.
justified. It's right justified.
Yep. I forgot
So
about
the
that.
1.0 takes up 10 spaces, but see how the like 1 point, we're using 3 decimal places of accuracy. So 1.0, can you still see me? Because I don't see you anymore. Can you still see Zoom?
Yeah. Yes.
Okay, so I don't see, this is, oh, I don't know if, I wonder if I'm in tablet mode. Sometimes I'm in tablet mode, which I don't mean to be, it messes up. Because I don't see you anymore. I don't see I don't see your faces anymore. Okay, well, when I close this, I'll see it. Okay, but the 1 takes up 1.000 is 6 spaces, and then, but we're actually going to use up 10, and that's why you see that big gap, and it's right justified. So you see value equal, and then after the equal, there's 10 spaces. There's probably like 4 blank spaces between the equal and the 1 on the first.
Yep, I see that. Thank you.
Okay. I don't know why it does this. Okay, so anyway, so there, but just to get back here, here's an example of the enhanced for loop right here. So I just wanted to, so you'll get more experience doing this. And so we'll do some more of this next time. I have some examples next time, more kind of interesting examples that we'll do on Monday. And then we'll talk a little bit about generics as well. So let me see. So I think the only way to get out of this now is for me to just to close this. See, now I see, I don't know why it does that. It could be because sometimes I accidentally get it's my computer, I think I know what I'm doing. But I guess I don't. Okay, so here, so let's just open up the second file. Let me make sure the second file is opened up with PDF annotator in case I need it. So that's the first really interesting topic. And now the next interesting topic is system array copy. And again, there's nothing remarkable about this. It's just a way of copying the contents of an array to another array. And so I'm going to share the screen again. And if I can find my system array copy, yes. Okay, so now I see you. I don't know why that happens. Okay, so you should see a document called system array copy. Does everyone see system array copy in the?
Yes.
Okay, because it says I'm sharing. Okay. Okay, so we're gonna so this is just kind of built in, and I used to see how. I don't know if I can make this a little bit bigger here. So if I do Control plus, okay. So I used to like if I wanted to copy, let's say I'll see X and Y have the same number of values, 5 values, but they have different addresses, right? So we allocate. Remember, what's actually stored in an array variable is an address. So X and Y have different addresses. But I want to copy the contents of X into Y. So one way to do it is with this for loop right here. We're copying the contents of X into Y. And that's how I used to do it. And then one thing I noticed is like, I'm using NetBeans and it keeps coming up with this warning, use system array copy. And it would do it, if you wanted, you could press a button, it would do it for you automatically. And so I didn't even know what system array copy was. So I looked it up. And I think it could be that Java programmers are encouraged to use system array copy. And it's just a built-in method remember how we have this system class, you go system.out.println. It's that same system. And it's this method in the system class called arraycopy. And it has 5 parameters. So in this case, X is your source. And X is the starting, that has the data. And Y is the target. And this method has 5 parameters. Okay, so X is the source. And then after X is the initial index of the source. And then there's the target array. And then after Y in this case is the initial index of the target array. And the very last value is the number of elements that we're copying. So it's 5 parameters. So it's array, int, int. So it's like array, index, number of values copied. So let's just see a few examples. Okay, so basically here's the signature, the source array, initial index of source, a target array, initial index of target, and the number of elements copied. So, so if you're just, in this case, they both have the same number of values, 5 values, and we're copying from, starting from 0 to, copying all the values. There's actually another, I think there's I can't remember, there's a way of just, I think every array has like a copy method. I'd have to look it up. To be honest, I don't really use it. But the system array copy is actually more flexible than, because we don't have to copy from 0 to 0. Right? See it's that the initial index of the source doesn't have to be 0, and the initial index of the target doesn't have to be 0. So here's one. Okay, so we have this array of size 100. Int X is an array of length 100. And let's just assign some values to it. So all odd numbers. So X of I is the ith odd number, like X of 0 is 1, and X of 1 is 3. So it's 1, 3, 5, 7, blah, blah, blah. Okay. And now we declare an array of size 8, different than size. X and Y have different lengths. The first one's 100, and the next one is 8. And okay, so what is this saying here? So we're going to copy from X, and we're going to start at index 6. And we're going to copy to Y, and we're going to start at index 2. Okay, and so let's see, what is index 6? So 6 is, what's the formula? 2 times I plus 1. So X of 6 is assigned 13. 7 is assigned 15. X of 8 is assigned 17, right? Because 2 times 8 plus 1. And X of 9 is assigned 19. And okay, so those are the, and we're going to copy, I'd say we're copying 4 values. So we're copying 4 values starting from position 6 of X. So we're copying X of 6, X of 7, X of 8, and X of 9 into Y, to Y. So X is the source array, start at position 6. And if you start at index 6, what do? It's 6, you just count with your fingers, 6, 7, 8, 9, I guess that's 4, okay. And so Y is the target array, and you're starting at position 2 of Y. So what assignments are you making? You're assigning X sub 6 to Y sub 2. You're assigning X sub 7 to Y sub 3, and so forth. X sub 8 to Y sub 4, and X sub 9 to Y sub 5. Okay, so one thing, students, do you see how that, see what I say are all values of Y initially 0? So whenever we assign memory to an array, every array has a value. Remember, a numeric array, if you don't initialize it, has all the values are 0. So initially all the values of Y are 0, but now starting from Y sub 2, we're assigning, so it should be like 0, 0, 13, 15, 17, 19. So that's what Y should be. So if you actually print out the values of Y after the system array copy, that's what you would see. X of 0 is 0, X of 1 is 0, but see, X of 2 now would be 13, right? Because we did this assignment right here. So it's not super exciting, but it's just a way of doing, just kind of maybe making the code a little more concise. And this way, hopefully programmers, I think the idea is that Java programmers use this one method, and it kind of standardizes our code. And in some ways, it's kind of a way to me of extending the language, right? So, we could actually use like a for loop to copy the contents of one array to another. But if everybody in the world, if all Java programmers use system array copy, then it just kind of standardizes the code. It's just like, so if you look at someone else's file, you go, oh, system array copy. I remember that from my math. That was like the favorite part of my Math 140 class. I wonder what my professor is doing now. Yeah, what was his name again? Okay, so anyway, okay, okay, so let's see here. Okay, so students, this is probably students. This is actually the highlight of the second part of the lecture. I'm not sure which is more interesting, the for each loop, or I kind of like the for each loop more than the system array copy part of the lecture. But as far as the system array copy part, this is the highlight of the system array copy lecture. So if you're not paying attention, pay attention now. So I have a short attention span. So let's see here. Source array. The source array can be same as the target array. Students forget this. So like a lot of times I give problems, programming assignments where I ask the students to use system array copy and the source and the target are the same array. And the students just do all these like convoluted things. See how there's X in the, see X is the, remember the first parameter is the source and the third parameter is the target. See how they're the same? So I'm starting from, I want to copy basically, if I can actually write here, we're going to, the system array copy is going to do, whoops, that's a 6. It's copying X sub 6 to X sub 2. And we're doing that, see, we're copying 3 values. So oh, PDF, this PDF annotator is not my friend sometimes. This is what this system array copy does. That's what that system array copy does. It says start, X is the source and X is the target, right? And it says start, this is the initial position of the source. So that's what I'm saying, X, and this is the initial position of the target. So, and then we're going to copy 3 values. Okay, so isn't that what we're doing? We're copying 3 values. We copy position 6 to position 2. So that's what we're doing. So that's all that system array copy does. Copies, assigns X sub 6 to X sub 2, X sub 7 to X sub 3, X sub 8 to X sub 4. And that's all it is. And then we print out the values. So it should be something like, oh, in this case, X sub I are the even values. So X sub 6 should be 12. X sub 7 should be 14. And X sub 8 should be 16. So it should be something like 0 to 12. It should go from 0 to 12 when we print it out. Let's see. Yeah. And see how we're doing the output. X sub 0 is 0 because 2 times 0 is 0. X sub 1 is 2 because 2 times 1 is 2. But X sub 2 should, it was initialized to be 4, but because of the system array copy, because we did that, X sub 6 is assigned X sub 2, X sub 2 is now 12. So not that this is so exciting, not that the example is exciting, what's exciting, students, which should kind of really make your weekend, is that the source and the target can be the same in a system array copy. Okay. So any questions about that?
Why is 5, 10?
Okay, because X of, okay, so we're copying, okay, so remember we only copied 3 values, right?
Yeah,
These are the 3 values that we copied. Right. Hello.
I understand. Yeah, I just don't understand why 5 is 10.
Okay, so remember, and then we go back to the original values. Remember, X sub I was originally defined to be 2 times I. And so that's, remember that was,
Yep. Okay.
yeah, right here. So remember, this is where we did the original assignment. So X sub 5 was originally assigned to be 10, and we never assigned anything to X sub 5. We never changed X sub, we only changed positions 2, 3, and 4.
Okay.
Does that help?
Yeah, that helps. Thanks.
Okay, so students, be careful. It's just like you can't go up the end of the array. So a system array copy can generate an index out of bounds exception. And okay, here, so the X has length 5, Y has length 100. And so we're going to do a system array copy We're going to, X is the source, Y is the target. We'll start at position 2 of X and then we'll copy to position 98. Uh-oh, but we're copying 3 values, right? So X of 2 is assigned to X of 9, Y of 98 because we started index 2 of X and we started index 98 of Y. Oh, X of 3 is assigned to Y of 99. But what is X of 4 is assigned to? We want to be, the next one is Y of 100, but Y of 100 doesn't exist. And so you will get an array index out of bounds exception. Your code, the compiler does not catch this, right? So there's no, you can type this in and there will be no red dots because the compiler doesn't know that you're about to go array index out of bounds. The compiler does not check our array indices, but it happens at runtime. And it's so fast, it's like, it's like, I don't even know, I don't even can blink our eye. Next thing you know, array index out of bounds. Like, what? What's going on here? Okay. Okay, so, and then here's just another example. In this case, it's the source that's going to generate the index out of bounds. So X has length 5, Y is length 100. Okay, we're starting at position, see, we're starting at position 3 of X, and we're copying 4 values. We're starting position 10 of Y, but that doesn't matter. But see, if you start at position 3, are there 4 values left? There's X of 3, X of 4, and that's it, right? See, X of 3 this is X of 3 right here. So you're trying to copy X of 1 to Y sub 10, right? We're doing this. And we're doing this. Whoops, it should be an X. But what happens? Then we're done with X, and it says we have 2 more to do, right? We've only copied 2 values. We want to copy, we're supposed to be now if X was big enough, we'd copy X of 5 to Y sub 12, but there is no X of 5. Once again, array index out of bounds. So that's it, so a system array copy. And so next time I'm going to start the lecture with some more examples, some interesting examples of system array copy, and some of the examples like are in the worksheets already that I put online. So I want to go through some of the worksheets next time for this, and then we'll start to talk about, I think, generics. Let me double check. I don't want to get your hopes up. I don't want your whole weekend to be, I can't wait till it's Monday because we're going to talk about generics, and then I come online and I'm talking about something else. So maybe, students, okay, maybe we'll talk about generics. If you like football, there's probably more interesting things than generics, but isn't the Super Bowl this weekend or something?
Yeah, Super Bowl Sunday.
Okay. So I don't think I'll watch it. I'll just read about it. Okay, but anyway, but I think it's it can be a lot of fun, I guess. Oh, yeah. You can tell me about it, Marcos. So let's see here. Okay, so that's it for this. So any system array copy question. Oh, here's some live chat questions. Let's see. Okay. And I think, does somebody have a question for me?
No, I was just going along with.
Okay. Oh, yeah. Thanks.
Yeah.
Yeah, I appreciate that. Just want to make sure. So I'm going to stop sharing, and maybe. So are there any questions about anything? So the quiz is online. I think you have 2 hours. I'll double check. I think you have 2 hours. And I'm going to post an assignment tomorrow. And next time we'll do some, I'll see how we I have the example up there. I want to show how we can use system array copy to expand, kind of fake expanding an array. And also I want to talk about how to loop through a 2-dimensional array with an enhanced for loop. And if you can understand that example, then you'll really, that'll show that you really have a good understanding of arrays.
And for homework, are you going to give us like the weekend to do the homework kind of thing? Like
it'll be a week from Monday.
Oh, okay, cool. Thank you.
So, because you might need some students might need my Monday lecture for the homework. So I'll give you a chance to think about it and ask questions. You know, you'll have, I'll post it tomorrow and then you'll have like a week to, there'll be like 5 or maybe 6 assignments in the course. They're not super hard. They're more harder than what I did in Math 130, or maybe more. I don't know. You can tell me.
Okay,
So,
cool.
Anybody else right now? I'll stick around until there are no more questions. But if you don't have any questions, I mean, feel free to stay. I'm not kicking anybody out, but just if you don't have any questions, feel free to go. You're allowed to go anytime. Remember, I don't take attendance, and my feelings aren't hurt if you leave in the middle. Just do what's in your best interest.
Have a good night.
Yeah, see you later,
Yeah,
Marcos.
thank you.
Yeah, see you later.
Wait, I have a question.
Yeah, go
Do
ahead.
you, do you post the recordings online as well?
Yeah, I
Or
posted.
how do I
The
explain it?
first one should be posted. I think I
Oh,
created a
okay.
module called videos or something.
All right.
I think I did.
Uh,
Oh yeah, so Kevin says yes. Hi, Kevin. So yeah, I did. Okay.
Right.
If you can't find it, let me, okay? What I
Thank
did,
you. Good night.
I uploaded to YouTube and then I close and YouTube closed captions it for me.
Oh, okay.
So
Good night.
yeah, see you later.
Professor, I have a question.
Yeah, go ahead.
So
Go
in the system dot array copy, the X is the target. I mean, the X is the source, and then the number after the X, what?
Yeah, so the first parameter is the source. So in this case, I guess I was always using X for the first one.
Right.
The third parameter is the target.
No, what's this? What does the 6 represent?
Okay, let me bring up the notes again.
Sorry.
No. Because otherwise we're just talking and I can't, no, absolutely no need to apologize. Let's learn it now. Let's learn it before the Super Bowl. Okay,
Right.
so, which is it, was it on here? Was it in my notes?
It was, yeah, it's up there. If you go scroll up, I think it's a. Let me see.
Let me see this. So this one.
It's on the 7. Slide 7. Oh yeah, you can do that one.
Okay, okay. Well, I'm at slide 7. Is this the?
Yeah, yeah. So the first X is the source.
Okay, so
then
this
the-
one, tell you, let's go back one because this is X, in this case, X is the source and the target. So maybe let's do this one. Yeah, because in this case, there's 2 different arrays. Okay, so X is the source, that's your starting point. And see, so what you're doing, and so the 6 means where are you going to start in X? See, this is the first the first operation is, can you see what I'm underlining right here?
Yeah, I can see.
That's your first operation. Okay, we start at index 6 of X. And we start at index 2 of Y. So that's what the numbers after, the number after X is the initial index of X. The number after Y is the initial index of 2. I mean, let me say it again. The first integer after X is the initial index of X. The integer after Y is the initial index of Y. See, that's the first operation that we're doing. We're assigning X sub 6 to Y sub 2. And then and we're going to copy 4 consecutive values. So then the next operation, we will be copying X sub 7 to Y sub 3. Does this help a little bit, Ernesto? Or?
Yeah. Sorry. So it's the first X is the source, and then the number 6 would be the initial index of X that is being copied into Y.
Yeah, and then in the initial, yeah. So X sub 6 is going to be copied to Y sub 2. And X sub 7 is going to be copied to Y sub 3. Let me see, am I answering your question? Why don't you ask one more time, make sure I'm asking.
Yeah, no, I think I get it. So the first, okay, so the first X, the source, the initial index, which would be 6, is going to be copied into the index Y of 2, right?
Right.
And then we do it, it goes again. So X index 6 gets copied to Y index 3.
No, X sub 7, you go to the next one.
Oh, so then the next
And
one.
then so there'd actually be 2 more. Then you'd be going one. Oh shoot, this P of n. See, then it'd be, the next one would be y sub 4 is assigned x sub 8. Sorry, my printing is pretty bad at this point.
Oh, so it's like a continuous line, like a
Right,
straight
right,
line,
and then
right?
y
So-
sub 5 would be assigned x sub. See, this last one is 4 values. We copy 4 values from x to 4 values.
Oh, okay. The 4 at the is the how many values we're gonna
Right,
copy.
right, absolutely.
I'm just writing it down. How many?
Okay, yeah, take your time.
One last time, so I can retain the information. So
No, it's good.
X of 6 is gonna be copied at y of 2, and then x of 7 is gonna be copied into y of 3,
Right.
and then so on and so on.
X sub 8 to y, and then the last one would be x of 9 to
Would be
y.
9,
sub
right?
9. And that's 4 sign
Okay.
statements, and that's it.
And that's it. All right. Oh, that's easy.
Yes, it's not too, and even the for each loop probably is a little more complicated, but it's not too bad.
And we wouldn't be able to copy through the enhanced for loop, right?
Oh, say it again?
Would we be able to copy through the enhanced for loop too?
No, see, the enhanced for loop, you don't use indices. You can't, so.
Oh, you're right. You're right.
So the enhanced for loop is good for like writing out values, but not for changing values.
It's for like reading data, like you said, right?
Reading data, right? It's only for reading data. If you actually want to change any values in your array, you have to go back to the math 134 loop.
Yeah. Got it. All righty. All right. See you next class then. Thank you.
Any other questions? Don't hesitate.
No. That's it. I got it.
Ernesto, just write me if you need anything, okay?
Yeah, of course. Thank you.
Okay, yeah, have a great night.
Likewise.